For number 3, we have a pulley system. We've got pulley A is moving at a speed of 1,500 rotations per minute and has 50 foot-pounds of torque and has a diameter of 15 inches. So I'm going to have pulley A. Then we have 3 pulleys, B, C, and D, all different sizes attached to a single output axle. So that means B, C, and D are all stacked on top of each other. So I've got B, and on top of that is C, and on top of that is D. So what we're doing is we have one single belt, and we can have multiple gear trains to change the gear ratio. So I'm going to take the belt and I can move it onto B, C, or D to change the gear ratio depending on what I need. So I'm going to keep reading. Part A says a speed of 1,700 rotations per minute is required when we connect to pulley B. So pulley B's speed is 1,750. And I need to use that to find the diameter and the torque. So in order to do that, I have to find the gear ratio comparing A to B. So I'm going to take my gear ratio, and I have my information about speed, so that's speed in divided by speed out. Gives me speed in is 1,500 divided by speed out is 1,750. And that gives me a gear ratio of 0.86. So I'm going to record that in my AB gear ratio spot, 0.86. I'm going to use that information to find my diameter because I know the gear ratio, I know the diameter in, and I can find my diameter out by using the gear ratio formula for diameter, D out over D in. Plug in what I know diameter is 0.86. Oh, 15. Nope, I don't know my diameter out. So this is my diameter out. My diameter in is 15. I got to get D out by itself, so I'm going to multiply both sides by 15. 15's cancel, and I'm left with 12.9. So 15 times 15 times 0.86 equals 12.9. 15's cancel, so I'm left with D out is 12.9. And lastly, it wants us to find my torque. So my gear ratio formula for torque is torque out over torque in. I know my gear ratio is 0.86. My torque out is unknown. My torque in is 50. To get the torque out by itself, I multiply both sides by 50. 50 times 0.86 gives me 43 foot-pounds. So 43 equals T out. All right, so now we're going to make believe that we're going to take this belt off of B and move it on to C. So now we have a completely different gear train set up. We've got a different system. So if we're comparing just A and C, B no longer counts. A is still my input, but now I have C as my output. And according to part B, I have 2,000 rotations per minute is pulley C. So I'm going to record that for my speed, 2,000 rotations per minute. I know the speed out and I know the speed in, so I can find my gear ratio using my in over out because it's speed. I'm going to take 1,500 divided by 2,000. And that's going to give me my new gear ratio of 0.75. Okay, now that I know the gear ratio, I can find my diameter using my gear ratio formula for diameter, which is D out over D in. Plug in what I know my new gear ratio is 0.75 times D out is unknown over D in is 15. Multiply both sides by 15. 15 cancels 15. 15 times 0.75 gives me a diameter of 11.25. And lastly, I'm going to find my torque using my torque gear ratio, which is T out over T in. Plug in what I know, 0.75 equals T out over T in is 50. multiply both sides by 50. Sorry guys, the last video cut out. So where we left off was we multiply both sides by 50. 50 times 0.75 give us 37.5. Record that in my data table. 37.5 is the torque output at C. So now we're going to make believe we're taking the belt, moving it from C to D. And now we're going to compare the two. So according to this, we say we have a speed of 3,250 rotations per minute for pulley D. So I record that here. Use that information. This is my new out. This is my in. So I'm going to use my gear ratio. For speed, I've got in over out. My gear ratio, we don't know. I've got my input is 1,500. My input is 1,500. My output is 3,250. If I divide 1,500 divided by 3,250, I get a gear ratio of 0.46. Now I can use that information to find my diameter. So I'm going to use my gear ratio formula for a diameter, which is diameter out over diameter in. I know my gear ratio is 0.4. I know my diameter out, unknown. My diameter in is 15. So to get diameter out by itself, I multiply both sides by 15, and I get 15. 15 cancels out 15, left with diameter out. 15 times 0.4 gives me a new diameter of 6.9. And then I can use my formula gear ratio for torque, which is torque out divided by torque in. Plug in my numbers. My gear ratio is, it's 0.46. So this math is still right. I have the answers written down over here. See, they're here. I forgot to write it. But if we do 15 times 0.46, we're still going to get 6.9. All right, so we're going to plug in 0.46 for my gear ratio. Torque out is unknown. Torque in is 50. To get torque out by itself, I have to multiply both sides by 50. 50 cancels out 50, so I'm left with 50 times 0.46. It's going to give me 23.